Imagine this scenario. Your company's website is crawling during peak hours. It becomes terribly slow. Customers are frustrated and complaining, revenue dropping by the minute. Now imagine that 3 AWS-certified professionals, Cloud Practitioner, CloudOps Engineer, and DevOps Engineer, they all get the same alert on their screens. But what happens next is completely different. One gathers information and escalates, another jumps in and fixes the problem, the third redesigns the entire system so that it never happens again. By the end of this video, you'll understand exactly how a Cloud Practitioner, CloudOps Engineer, and DevOps Professional would handle this crisis. And more importantly, which certification path is right for your career. Hey everyone, welcome back to the channel. If you are new here, I help people navigate their cloud careers and AWS certifications. Today we are doing something different, a real-world scenario breakdown that will show you what these AWS certifications actually mean in practice. Not just exam facts, but what these professionals do day to day when problems hit. If you're studying for any AWS certifications or wondering which one to pursue next, this video is going to be incredibly valuable. So go ahead and hit that like button, subscribe if you haven't already, and let's get into it. Before we jump into our scenario, let's quickly cover the 3 certifications we are comparing today. First up, AWS-certified Cloud Practitioner. This is the foundational level certification. This exam covers basic cloud concepts, AWS services at a high level, security fundamentals, and pricing models. Here's the key thing. You don't need hands-on experience to pass this exam. It's perfect if you're switching careers into cloud, or if you're in sales, marketing, project management, or support roles where you need to understand cloud but aren't building infrastructure yourself. Next is the AWS-certified CloudOps Engineer Associate. Quick note here, this certification was formerly known as SysOps Administrator Associate. AWS renamed it to better reflect what cloud operations professionals actually do. This is an associate level certification. The exam is 130 minutes and 65 questions, and here's what makes it different. It includes hands-on scenario questions. This certification is all about operations, deploying applications, managing and operating things in AWS, implementing security controls, troubleshooting issues, and optimizing costs. It's ideal for cloud operation engineers, cloud administrators, system administrators transitioning to cloud, and site reliability engineers. And finally, we have the AWS-certified DevOps Engineer Professional. This is the professional level certification, the top tier. This certification focuses on advanced topics, implementing CI/CD pipelines, infrastructure as code at scale, configuration management, monitoring and logging strategies, security automation, and high availability architectures. This is for senior DevOps engineers, cloud architects with a DevOps focus, technical leads, and engineering managers. So let's break down the key differences between these 3 levels. Cloud Practitioner is your information gatherer. They understand what AWS services can do and can communicate cloud concepts to others. They work under supervision and focus on understanding the basics. Typically 0 to 1 year of cloud experience. CloudOps Engineer is your problem solver. They know how to operate AWS infrastructure. They work independently, executing solutions to keep systems running smoothly. Usually 1 to 3 years of hands-on experience. DevOps Professional is your system designer. They know why to architect systems in specific ways. They provide leadership, make decisions, and design solutions that scale. 3 to 5 plus years of experience, often with team leadership responsibilities. Think of it as a ladder. Cloud Practitioner knows what, CloudOps Engineer knows how, DevOps Professional knows why. Now let's see this in action with real scenarios. Alright, here's our scenario. It's 2 p.m. on a Tuesday afternoon. Your e-commerce website normally loads under 2 seconds, nice and fast. great user experience. But right now, users are seeing 15 to 25 seconds page load. Some pages aren't loading at all. Shopping carts are timing out. Customers are abandoning their purchases left and right. Your support team is getting absolutely bombarded with complaints. Social media is lighting up with frustrated customers. Revenue is literally disappearing by the minute. Every second this continues, your company is losing money. The CloudWatch alarm triggers. The same alert pops up on 3 different screens. 3 team members see it, each with different AWS certification. One is certified as Cloud Practitioner, one is certified as CloudOps Engineer, and one is certified as DevOps Professional. Let's see how each one responds. First up, our Cloud Practitioner. They see the alert come through. High response times. Customer complaints. They understand this is serious. Here's what they might do. As a step 1, they immediately check the AWS service health dashboard. They are thinking, is this us or is it AWS-wide problem? They need to rule out an outage on Amazon's end. The dashboard shows all green. Everything is operational, so this is definitely a problem with your specific infrastructure. Step 2. They open up CloudWatch and look at the basic metrics for the web application. They navigate to the EC2 dashboard and check CPU utilization. And there it is, CPU usage is spiking at 95–99%, way higher than normal. Step 3. They take screenshots. They capture the CPU graph, their CloudWatch metrics, anything that shows what's happening. Documentation is key. Step 4. They create a support ticket in the internal ticketing system. The title reads, High CPU usage on web servers during peak traffic, site performance degraded. They attach their screenshots and add details about what they have identified. And step 5. They escalate to the CloudOps team. They send a Slack message or email. Hey team, we've got a performance issue. Customers are experiencing slow load times. I've created a ticket number, something with all the details. Need someone to take a look at it as soon as possible. Total time for that is about 15 minutes. And here's the thing. They've done exactly what they are trained to do. They have identified that there is a problem. They have documented where it is happening. They have gathered the key information, and they are escalating to the right people who actually can fix that. They can't make infrastructure changes themselves. They don't have the permission to do that, or they do not have deep technical knowledge as well. They've been the early warning system. They have communicated clearly and efficiently. Problem identified, information documented. Team notified, that's the Cloud Practitioner's responsibility. Now let's see how the CloudOps Engineer handles the same situation. They get the same alert, high CPU, degraded performance, but they don't just look, they investigate. And they don't just investigate, they act. First, they dive deep into CloudWatch. They are not just looking at CPU, they are examining memory utilization, disk I/O, network throughput. They want the complete picture. Next, they check CloudWatch logs. Are there any application errors? Any stack traces, any patterns in the logs that might explain what's happening? Then they examine the autoscaling group configuration. They check the scaling policies, the activity history. Have new instances been launching? If so, how long are they taking? They look at the load balancer. Are all instances passing health checks? Is the traffic being distributed properly? They check also RDS database metrics, and database connections, CPU usage, IOPS. Could the database be the bottleneck? And here's what they discover. Yes, CPU is high, but the real issue was that autoscaling policy is configured to trigger at 70% CPU. And when it does trigger, new instances take 5 to 7 minutes to launch, pass health checks, and start receiving traffic. By the time those new instances are online, the CPU has already spiked to 90+%, and users are experiencing terrible performance. The autoscaling is too slow and too conservative. Okay, they now know what's wrong. They manually increase the desired capacity of autoscaling group instead of waiting For the policy to trigger, they add 5 more instances right now. They watch the metrics, new instances are launching, traffic is being distributed properly, CPU usage on each instance starts dropping, response time improves. Within 5 to 30 minutes, the website is back to normal performance, crisis averted. But they are not done. A good CloudOps engineer doesn't just put out fires, they prevent them from starting again, so they fix this problem long term. And total time to resolution is about from half an hour to an hour, or even 2 or 3 hours from alert to complete fix. Problem solved, system optimized, future incidents prevented. Documentation created, the site is running smoothly. Auto-scaling is more responsive than before. The team has monitoring in place and it didn't require major architectural changes, significant cost increases. That's operational excellence. That's what CloudOps Engineer brings to the table. Now let's see how the DevOps professional approaches the same situation. They get the alert, they see the high CPU, and they ask fundamentally different question. Not what's broken, not even how do I fix that. They ask, why did this happen in the first place, and how do we architect our way out of this problem forever? They start with everything that CloudOps Engineer checked: CPU, auto-scaling, load balancer, database, but they go deeper. Analyze database query performance, they check the deployment history, was their code released recently, could a recent change have introduced performance degradation, and so on. They examine the CloudFront CD and configuration, how efficiently caching static content, and other too many requests hitting the same origin server. After this deep dive, they identify the real root cause. 1. The monolithic application isn't resource efficient. Scaling the entire app just to handle one component's load is wasteful. 2. There's no caching layer between the application and the database. Every request hits the database directly. 3. Database queries could be optimized, but there are no read replicas to distribute the load. 4. Static content isn't being served efficiently. Final verdict. Auto-scaling configuration was a symptom, but not the disease. As a strategic solution, they design a multi-phase transformation. For immediate relief, they approve the CloudOps engineers' auto-scaling fixes that solves the urgent problem. Users are happy again. Phase 1 of the DevOps Professionals plan takes 1 to 2 weeks. Quick wins, high impact, low effort. They implement Elasticache, Redis, Memcached to cache frequently accessed data. Database queries drop automatically. They add RDS read replicas to distribute read traffic across multiple database instances. They optimize CloudFront caching rules to serve more static content from edge locations. Phase 2 takes 1 to 2 months. This is modernization. They containerize the application using ECS or EKS. Now different components can scale independently. They begin breaking the monolith into microservices. The shopping cart service, product catalog, and user authentication become separate services that can scale based on their individual needs. They implement API gateway with built-in caching and throttling capabilities. They create infrastructure as code using Terraform or CloudFormation. Every single piece of infrastructure is version controlled and reproducible. Phase 3 takes 2 to 3 months. This is the optimization and innovation. They move appropriate workloads to Lambda functions. Some services don't need dedicated service, they can run serverless. They implement DynamoDB for session management, fast, scalable, and fully managed. They implement chaos engineering tests. They intentionally break things in controlled ways to verify the system's resilience. They create cost optimization dashboards with automated right-sizing recommendations. And they developed a comprehensive training plan so that the entire team can operate this new architecture. That's strategic thinking. That's what a DevOps professional brings to the organization. Alright, here's the bottom line. All these 3 certifications are valuable in the market. Employers are actively looking for all 3 levels, but they prepare you for very different roles with very different responsibilities. Cloud Practitioner is your foundation. It proves you understand cloud concepts and can communicate effectively about AWS. CloudOps Engineer makes you operational. It proves you can deploy, manage, and troubleshoot AWS infrastructure in production environments. DevOps Professional makes you strategic. It proves you can architect scalable, resilient, automated systems and lead technical initiatives. If you found this video helpful, please hit that like button. It really helps the algorithm show this content to other people who are studying for these certifications. Subscribe to the channel if you want more cloud career advice, certification tips, and real-world scenario breakdown like this one. Thank you so much for watching. I'll see you in the next video.